Hello, I'm Richard Alvero. I'm going to be giving a brief overview of photonic emission analysis and the security flaws it exploits. First, a little about myself. I'm a freshman majoring in computer engineering who enjoys to read, crochet, and play video games in my spare time. And now onto photonic emission analysis. When performing photonic emission analysis, the device under test is run using a modified program that rapidly switches it on and off. Logic gates in the circuit are turned on and off in parallel with the device, and the first ones to be turned on are the ones essential to the function of the device, such as the clock, the counters, and the ring oscillators. While the device is being rapidly switched, these logic gates will rapidly switch states as well, emitting photons. As you can see, the backside of the chip has only silicon substrate covering the logic gates, while the front side has metal interconnect obstructing the gates. Since near-infrared photons can easily pass through the substrate, they are accepted and analyzed through the backside of the chip. In order to run the device under test using the modified program, the device is soldered onto a field programmable gate array upside down, exposing the silicon substrate covered backside. This gives the attacker easy access to the photons that are released. Pictured is the PHEMOS 1000 and its photon emission microscope, a machine capable of detecting emitted photons and outputting data to a computer. The results shown here were acquired using photonic emission and depict key elements of a device. The clock is on the top left and was located by first filtering out data-dependent emissions by supplying unchanging data to the device. Then the specific location was determined by identifying the area with the highest switching frequency, since the clock is the only signal that constantly switches states. The ring oscillators, seen in the bottom left, were located by identifying inverters and their patterns of logic gates. And a third visual of photonic emission is shown on the right and displays a challenge bit in its on and off states. Photonic emission analysis exemplifies a few key security issues. First is photonic emission analysis can allow the attacker to extract the full AES security key. And second is that photonic emission analysis allows for logic gate states to be extracted, as well as other data that can aid a memory side channel attack. And here are my sources.